Pre-calculus in 5, 4, 3. Hey kids, guess what? It's time for pre-calculus with the live studio audience. And now it's time to do Tidbits Part 1, 9-5, which has been dubbed implicit differentiation. How about that for a fancy title? Implicit differentiation. Mr. Wade, that sounds too hard to do. Or no, I mean, Mr. Wade, we're honor students. Come on, challenge us, okay? All right, here we go. Implicit differentiation. Now, you remember earlier in the year what differentiation is a fancy word for? That's taking a derivative, okay? So all we're doing is a derivative. Let's start off with the first question, which is x squared plus y squared equals 36. What is that? That is a circle of radius 6. There we go. It's just a circle. Now what we're going to do is we're actually going to take the derivative of the circle, right? Do you remember if this form is implicit or explicit? Explicit. If you have a mixture of x's and y's all mixed together, it's actually implicit, which is how all equations started in the beginning. They didn't even have like y equals equations until Euler, the #1 mathematician of all times. Okay? So here's the deal. We need to take a derivative. Now all the derivatives we've done before, let's do one off to the side. Let's just do an easy one. Like y equals x cubed. Okay? If you had to take the derivative of y equals x cubed, what would happen to the x cubed?
Turns x squared.
Okay, 3 x squared.
Chain rule 1.
The chain rule of the base is actually times 1, but you don't really put it, right? But over here, do you say that the derivative of y is 1? We don't do that, do we? The derivative of y is y prime. So the y gets the prime, but the x actually goes through all the derivative rules, right? Okay? So today we have two choices. Every derivative, and I've given you probably 200 derivatives this year, and every derivative has had y equals. Okay? The y was always by itself. Today we have one where the y is not by itself. So, one option, what could you do here? Solve for y. You could solve for y, which is known as the explicit form. Okay? Which didn't happen until later. Or, that one kind of worries me though. If we solve this for y, when I get to the y squared part and I try to go from y squared to y, what do you have to do? Square root of both sides. As soon as you square root of both sides, plus or minus. I don't know about that. I mean, it is plus or minus, but I don't know about taking the derivative. That kind of scares me. Because if we have to take a derivative of a plus or minus, we have to do like 2 different cases and do all this stuff. That sounds complicated. It's got to be better. Here's the other option. You could do what is called an implicit derivative or implicit differentiation. Okay? All right? So, here's how to do an implicit derivative. What that means is don't solve it for y if it's cumbersome and hard to do. Now, if it's easy to solve for y, just solve it for y. But if it's hard to do, like here when you get the plus or minus, you can just take the derivative in its current state right here. Okay? New trick. So here's the trick. If you had to take the derivative of x squared, what would be the derivative of x squared? That would be 2x. Okay? Plus carries. Okay, oh wait, let me mention this also. It's 2x, but what is the base over here? 1. The base is x, so the derivative of x, or the chain rule, was what? That was times 1. So there's like a little secret times 1 there, right? Doesn't affect that. But it matters over here. What is the derivative of y squared, would you think? 2y, just like the 2x, right? Drop it to the first power, but then the chain rule will be inside. What is the derivative of y? It's y prime, it's not y. That's the only difference right there. How about that? So the derivative of x is 1, but the derivative of y is y prime. If you do that, you will get all your implicits correct. Okay? But it's so much easier to do for a problem like this, though. Then what about the 36?
0.
Okay, derivative of 36, which is a constant, is 0. Okay? And there's your derivative. All right? Now, yes, what do we always solve for when you write the derivative? You solve for y prime. You write y prime equals, well, it's always by itself in the past. For the first time, y prime is not by itself. But we can get it by itself. Okay? let's see, which one of these doesn't belong here? Okay, get this, subtract it over. So 2y, y prime equals negative 2x. Okay, a little bit of algebra here. Can you solve for a mystery variable? Okay. Yeah, right now it's multiplying. The opposite would be division.
It's just like dx over dy.
Okay? Yes, that is correct. So, or the other way around.
Yeah.
Yeah. So you can cancel those out. You get y prime equals, and you know what? This doesn't always happen. We got lucky here. We can cancel out the 2's. Nice answer right here. Okay. And there is your derivative right there. Now there's one big difference with implicit derivatives. Normally, don't we just have x's?
Yeah.
In the implicit derivative, you often have x's and y's all mixed together. Okay? Which is fine. It's still a derivative. Okay? And kind of wraps up 2 cases into one anyway. So it's very nice. Very nice case. Okay? And that's how you do an implicit derivative. How about that? That was actually discovered for the first time by the 3rd greatest mathematician of all times.
Sir Isaac Newton.
Also the greatest scientist of all times, Sir Isaac Newton. He figured out how to do implicits. And then way after he was gone, that's when they actually figured out, hey, we can actually just write equations with y equals, or f of x equals in the beginning. So that came later. Interesting. All right. And by the way, just out of curiosity, what is a derivative anyway? What does it measure? Hey, isn't that steepness we've been talking about for a long time, right? So that's actually the slope. Now wait, what did we just take the derivative of? Circle. That formula is the steepness all around the circle. Right? If you're at the top, your slope is what? 0, it's level. Yep. If you're on the sides, it gets really steep, doesn't it? Okay? And that's what that formula is right there. That was the slope. Okay?
Is this like assumed to be centered?
Well, yeah, because it's at 0, 0.
Yeah.
Yep. Okay. All right.